Chapter 9 now, but back in chapter 3, we learned about sequences. And the type we studied back in chapter 3 were called arithmetic sequences. Anybody think they remember anything about arithmetic sequences? What is a sequence, first of all? Series of numbers. It's a list of numbers, and it has a beginning, and then at the end of them typically is an ellipsis, it's called. Not an ellipse, but an ellipsis, which means there's 3 dots, meaning it goes on forever in the pattern that it is actually in. So when we had an arithmetic sequence back in chapter 3, here's what we looked for. We looked for a common difference. If it kept changing by the same amount from one term to the next, terms being the numbers in the sequence, if it kept changing by the same amount, you could add 6, or maybe you could subtract 3, or whatever, then you said it was an arithmetic sequence. Well, here we're studying geometric sequences. So sequences don't have to be arithmetic. There are different types of sequences. In a geometric sequence, it says each term is multiplied by the same number to get the next term. And this number is called, I would like you to underline this because this is going to be a really big deal. We're going to use it a lot. That number that you multiply by to get the next term is called the common ratio. And we abbreviate that in a formula with little r. Okay? So the common ratio. If there is a common ratio, then we say it is a geometric sequence. So this is a sequence of numbers. They've just shown like the first 4 terms. We have 3, 12, 48, 192. To get from one term to the next, you keep multiplying by 4. And so what we're going to do is we're going to first of all, we're going to determine if a sequence of numbers is a geometric sequence. We will divide each term by the term before it. So if you start at the end, it makes it less confusing. So 54 divided by the term in front of it divided by 18 is 3. And then they moved on to, okay, now take the 18 and divide it by its previous term, 6, got 3 again. Now take the next term, 6, and divide it by the previous term, and they got 3 again. But we can't divide 2 by the previous term because 2 is the first term of the sequence. So we would say this is a geometric sequence with 3 being the common ratio. If we wanted to find more terms of this sequence, this geometric sequence, we would just multiply by 3. So what's the next term of that sequence? What would the next term of that sequence be?
162.
162. 54 times 3. You are going to probably, at times aren't your calculator today. 54 times 3 is 162. And we can keep finding terms of that geometric sequence. I just continually multiplying by 3. In the next one, determine if the 5, 10, 15, 20, and so on is a geometric sequence. 20 divided by 15, start at the end. 20 divided by the previous term, well, that's 4/3. Don't want to do it as a decimal because it's not a nice decimal. 15 divided by 10, 3 halves. 10 divided by 5, 2. This is not a geometric sequence because there's not a common ratio. What kind of sequence do you think that is, though? It's an arithmetic one, isn't it? Because what happens?
It's added, like 5 is added every
5 is added every time, so this happens to be an arithmetic sequence. But we were just checking to see if it was a geometric sequence, okay? So, let me show you how you're going to show work in your homework today. Determine if each sequence is a geometric sequence, show support. So what we do is we start with the last term and put it over the term in front of it. And let's just simplify them as fractions if we can't divide them out to be integers. So 4/8, what's that become? 1/2. Our next one would be 8 divided by 16. What's that one become? 1/2. Now you can't stop there though, because sometimes it could fool you into thinking it's a geometric sequence. You can be like, okay, well I got 1/2 twice, so it must be. Not necessarily. You want to go all the way through with all the terms that they have provided for you and make sure. Is 16/32 1/2? Yes, it is. So there's our support, and we're going to say is a geometric sequence. with R equals 1/2. Our constant ratio, our common ratio. You'll hear it called both, constant ratio or a common ratio. Okay. So you do number 2 now. You set up number 2 and see what you think. Is number 2 a geometric sequence? Ted?
Could you go like 16, 16?
Nope, you don't want to do, you want to work with a term and its previous term. You never work from a term to its next term. You always work from a term back to its, and then divide by its previous term. So what happens? You get a constant ratio of -2. Okay, so we're going to say is a geometric sequence. That's what the question was. Determine if it is, if that sequence of numbers is a geometric sequence. And then if it is, we're going to say what is R equal to. And this time it's -2. So take note of something. When the R value is negative, what's true about the sequence?
Has a negative and a positive, and then
Yeah, it's alternating signs. You have a negative, a positive, a negative, a positive, or it could be a positive, negative, positive, negative, but alternating terms, every other term is negative, or they have opposite signs. Okay? So anybody have questions on that one? Okay, then let's move on to number 3, decide if it is. So what are we going to start with? 8/6. 8/6 is what fraction? 4/3, okay. Now we'll do, what would be next? 6/4. 4/3? This is what you're going to want to do. You're going to want to be lazy and not think and say, well, it must be 4/3. It's a fraction and it doesn't divide out to a nice, integer number. So is 6/4 4/3? What is it?
2, 3 over 2.
It's 3/2, yeah. And we'll just do the last one for the fun of it. What is 4/2? 2. But it already broke down right away after our first 2. It is not a geometric sequence, but I would suggest you do it just in case you made a mistake in that section. Okay? Because typically what should happen is all 3 of the ratios should end up being different. So is not a geometric sequence. We could not come up with a constant, also known as a common ratio. And we have our support there for it. Okay, and our last one. We're going to, by the way, you can start at the beginning, but if you start at the beginning rather than at the end, you can't do what Todd's question was, can I do 50 divided by 10 instead? No, we could do 10 divided by 50 though. Start with the second term and divide by the previous. You always want to divide by a previous term. So we could do 10 divided by 50, then we could do 2 divided by 10, and then we could do 0 divided by 2, or 0.4 divided by 2, 4/10 divided by 2. We're still doing the same 3 divisions, just in a different order. So, what is 10 over 50? 1 what? 1/5. What is 2 over 10? 1/5. What's 0.4 divided by 2? Oh, is that what your calculator told you, or do you just know it's 1/5? Just do we want it to be? doesn't it first become 0.2? Right? And then 0.2 is the same as 2/10, and 2/10 is the same as 1/5? Yeah. Okay, so is a geometric sequence. And what are we going to say? Besides that? With r equals 1/5. Okay, so determining if a sequence of numbers is geometric or not. So let's go back and look at number 3, the one that was not geometric. Is it of a type that we do know about? What is it? It's an arithmetic sequence with its common ratio, with its not its common ratio, with its common difference being what? 2. Yeah, that's a common difference of 2. Keeps increasing by 2, so it would be a positive 2. Okay. Anybody have questions on being able to determine if you have a geometric sequence or not? Okay, flip over to the back side and study that example. So if they tell us it's a geometric sequence, in reality, we do not have to do it 3 times because they've already told us it's a geometric sequence. And to be a geometric sequence, it has to have that common ratio. So you can just do one division problem and then use that, but you're going to show, even if you use your calculator, that's totally fine, but you need to show what are you actually doing to get that in your calculator. So when we do it in number 5 here, they've already said, find the common ratio in each geometric sequence below. They've already told us it's a geometric sequence. So we can just set up one division problem to get our R value, to get our constant ratio, our common ratio. So which division problem do you want to set up? 125 divided by 25, okay. How many 25s are there in 125? 5. Whoa, where'd my document go here? Okay, I added a new one in there I don't really want. Okay, so if 125 divided by 5 is 5, then, and they want us to find the next 3 terms, we're going to start with our last term, and we're going to show that we're going to multiply that by 5 to get the next term. So what's 125 times 5?
625.
625. 625 times 5.
3,125.
3125, 3,125. And now 3,125 times 5 is?
15,625.
Okay, they're getting pretty big pretty fast, aren't they? So here's our next 3 terms that they wanted us to know. Okay, so that's the work you need to show. You can use your calculators to do the multiplying for you, but show what you're going to put into your calculators. Where did you get those numbers from? Any questions? Okay, find the common ratio for the next one. What's the common ratio for the next one? I get -2. Again, doesn't matter which pair of numbers you use, as long as they're consecutive, they follow each other, and you take a term and divide it by its previous term. Be careful, okay? And then you can start. We start with 48, multiply by our -2. What's that? -96. Now -96 will get multiplied by -2. 192. Now 192 will get multiplied by -2.
384.
How about -384?
Do that.
Okay. And again, we want to make sure that the positive negative pattern continued on. We had it started with a negative, positive, negative, positive. Our next one is negative, that's good. Our next one is positive, and our next one is negative. So we kept that pattern going. I want to make sure of that too, double check that. Okay, questions at all about that? Okay, so we're just kind of practicing here together. This is part that's probably the most confusing, is making sure you get your division problems set up correctly. So we could do 13.5 divided by 9, we could do 9 divided by 6, we could do 6 divided by 4. What is our common ratio this time? 1.5. Okay, now, because there is a decimal in our sequence, we can work with the decimal. We want to just keep the same name type going. If they're working with fractions, we're going to keep them fractions. If they're working with decimals, we'll work with decimals. Okay, so this did have a decimal in it, so we will just keep it as a decimal and do our multiplying. So what do we get for this one? Pardon?
20.2.
Okay, 20.25. And our 20.25 now gets multiplied times our 1 5/10. 20 and 25 hundredths divided by, or not divided by, times 1 1/2, 1.5.
30.375.
Okay, 30.375. The decimal should start getting longer. The decimal places, I should say, after. See if I check me out, make sure I'm right. Okay. Any concerns about that one at all? Why do we do it in decimal form? Why didn't we use 1 1/2 or 3/2? Yeah, there's a decimal in the sequence. Okay, let's look at the next geometric sequence. Are we going to work with decimals in this one? No, we're going to work with fractions, although it's looking like possibly the fractions have kind of gone away anyway, haven't they? What should we do? What division problem do you want to do in this one? 2/1. Pretty easy one to do, right? So our common ratio is 2. This isn't, even though it had fractions in the beginning, it's going to turn out not to be bad at all. 2 times 2? 4. 4 times 2? 8. 8 times 2? 16. That was pretty harmless. Okay. Okay, so first of all, we were making sure we understood how to determine if a sequence is geometric. Then we did, when we know it's a geometric sequence, how can we find more terms of it? And the last thing that we're going to do today is, like we did with arithmetic sequences, what if they want us to find a term further down in the sequence? So our example in this one, it says find the 8th term in the geometric sequence. 5, 10, 20, 40. We were given how many terms? How many terms were we given? Make sure we understand what terms. How many terms were we given? 4. 1, 2, 3, 4. Okay. So again, if it is a geometric sequence, we really only need to do one division problem. We don't really need to do all 3 of them. We need to find what the constant ratio is. And we have 2 methods of how we can do this. Now I'm going to advise you to learn method 2. Because if they ask you to find the 50th term, you're not going to want to have to keep multiplying like method 1 does. So in method 1, they are, after they found what the common ratio was, they actually just kept multiplying. So 40 times 2, 80. 80 times 2, 160. 160 times 2, 320. 320 times 2, 640. And said, okay, the 8th term is 640. What if it was the 50th? Isn't there a shorter way we could have done that? So here they're taking our method 1 and they're saying, well, let's look at what happened there. The first term was 5. And that 5 actually ended up getting multiplied by 2 how many times? So 5 got multiplied by 2 to get 10, and 10 got multiplied. So in reality, 5 got multiplied by 2 how many times? 7 times. So if it got multiplied by 2 7 times, we could write that as 2 to the 7th power, couldn't we? So what we're going to do is, just like we did when we had an arithmetic sequence, we can come up with a little formula we should be able to use that will help us get that number. So the formula for the geometric sequence, would you circle that on your page there, put a big circle around that so that you use it and learn it? A sub n, in other words, n, remember, is the term number. So whatever term number you want, you would substitute in there for n. In this case, it's 8. And then a sub 1, remember, the same as with the arithmetic sequence, the sequence always has to start somewhere, so a sub 1 means the first term of the sequence. And then r is our common ratio, and then n minus 1. Why do we subtract 1 from n? Because if we're looking for the 8th term, we didn't multiply that first term 8 times by 2 8 times, we multiplied it 1 less time, we multiplied it 7 times. So using the formula, here's them substituting into that formula right here. A sub 8 equals 5, the first term, times 2 raised to the 8 minus 1 power, which then becomes 5 times 2 to the 7th. 2 to the 7th is 128. 128 times 5, still get the same answer. So we're going to use that. We're not going to use method 1, okay? So let's do number 1. A sub 1 is 7. What are they telling us when they say a sub 1 is 7? What are they telling us?
First term is 7.
First term of the sequence. Yep, they just told us what the first term of the sequence is. R equals negative 2. What are they telling us?
It's the common ratio.
That's the common ratio. That's the multiplier. That's what you're going to multiply by. They want the 10th term. Okay? So we're just going to fill in they kind of set up the formula here for us. A sub 10 equals, what's going in the first box? 7, the first term. What's going in the parentheses box? Negative 2, the common ratio. Why do you, those parentheses are there for 2 reasons. One of them is showing multiplication, and the other reason is it's showing that you have a negative number that's going to be taken to a power. And then we're going to do to the 10 minus 1 power. So we're going to put a little 10 up there in that box. So what we really have here is, do we take the 7 times the negative 2? No. Order of operations says do the exponents first. So that 7 is going to stay there. And this is going to become negative 2 raised to the 9th power. We'll just do the 10 minus 1 thing. So next thing you're going to show me is what is negative 2 raised to the 9th power. What is negative 2 to the 9th power? Well, I'm thinking it better be negative because we're taking it to an odd power. And it's negative what? 712?
500.
512. I didn't think it was 700. Okay. Negative 512, and now we just have our final step, which is multiply the 7 times that negative 512, and we will say that a sub 10, our 10th term, is negative
3,500.
84. Okay. Here we go. There's our 10th term. Okay, you apply that process now to number 2. Number 2. You get the same answer I do. I'll work it, you work it. Is anybody in agreement with me? Feeling like we got it? Okay. So any questions at all? Okay, well, there they are, they told us what all the parts of the formula were. Now they don't. We're going to actually give them their algebraic name. So it says, the first term of a geometric sequence is 2. So what are we going to say that is? A sub 1. So a sub 1 is 2. We're going to write that down. And the common ratio is 3. What are they telling us there? So how are we going to write that? R equals 3. What is the seventh term? So what do we put to that? Well, no, what variable is that going to represent in our formula? Our n, isn't it? We have 2 places where there's an n we have to talk about in our formula. We haven't written it yet. Maybe that's why we're not familiar with it yet. Let's write it. A sub n equals a sub 1 times r raised to the n minus 1 power. There's our formula. So we are looking for the 7th term, so a sub 7. We know that a sub 1 is 2, our first term. We know that r is 3. And we know that n is again 7. Okay. So we just substituted into our formula those things that we determined that they gave us, really, but we gave them their algebraic notation. And now we can figure out what the 7th term of this sequence is. So we have 2 times 3 to the 6th power, 2 times, what's 3 to the 6th power?
729.
729. So our 7th term is 1,458. Is that right? Okay. Okay, and our last one. Find the 12th term in the geometric sequence. Negative, or 5, negative 15, 45, negative 135. Okay, they don't say anything but what they show us the sequence as it starts, tell us they want the 12th term. So, we need the a sub 1 term, right? So what's our a sub 1 term? 5. We need r. How are we going to get r? Pardon?
You can find it from the terms that we have.
Yeah, we're going to do a division problem, right? Let's do an easy one. How about negative 15 divided by 5? Should we do that one? Negative 15 over 5, so our r value is negative 3. And our n value is, and I want the 12th term. Okay, you go ahead and substitute that into our formula and find the 12th term of that geometric sequence. I'm thinking we better end up with a negative number, because every second term is negative and 12 is a multiple of 2. You agree with me? And we don't have calculators, we Those of you who have calculators, check me out, right? Yeah? Okay. So when we need to find the term further down the line, let's use this little formula because it's actually a lot quicker than I'm sure on the paper, you don't have to show me. Multiplying by that number, remember I have to show that, so we want to show that 8 times, so time for homework.